We're going to jump in and do some maths today. Hope you're well. We're going to just crack on with some simultaneous equations. Now, I'm going to assume that you haven't come across these before, and so we're going to start building from the ground up. Do you know what simultaneous means? Simultaneous. If you're unsure, it means at the same time. Cool. So we can see two equations here. One is 2x minus 5y equals 11, and one is x minus 4y equals 4. Simultaneous because we've got two at the same time. And what it means as well is that this y and this y have the same value. Okay, we don't know what it is yet, but they have the same value in both of these equations. Same idea with the x's. This x and this x are the same across the two equations. Cool? So, at this stage you'll probably be used to seeing something like x minus 10, say, equals 4. Now what's different and what's the same? Here we've got x, yes, but what do we not have? We don't have the y, exactly. So in normal linear equations, or other equations that you might have seen, quadratic and so on, at this stage we're just dealing with linear, you've got one variable or unknown. Cool? In simultaneous equations, you've got two. Cool? So, how would you solve this, where we've got just one unknown? Yep, okay, cool. So we'd add 10 to both sides. Fab. And we get our solution. X minus 10 add 10 is just x. 4 plus 10 is 14. We get x equals 14. Cool? However, if we now introduce, rather than minus 10, the minus 4y, which we're dealing with in the question, what does that change? X could be 14, yes. Let's say x is 14. But would that mean that y equals? How would you solve this? Subtract 14 from both sides, minus 4y equals minus 10. Divide both sides by negative 4, y equals negative 10 over negative 4, positive 2.5. Okay, but what if x equals 8? Then we'd have 8 minus 4y equals 4. So again, we'd solve following the same method, subtract 8 from both sides, minus 4y equals minus 4, divide both sides by minus 4, y equals 1. Which of these is our solution, or the solution? Well, they both work, yeah. They're both correct. Okay, so what are we seeing here? Is it just, I'm used to, like we said, x minus 10 equals 4, x equals 14. I'm used to just having one solution. Okay, but that's when we've only got one unknown. Yeah, exactly. So now that we're looking at a question that's got two unknowns, it's not so straightforward, okay? So, an equation with one unknown, yes, we can solve it and has one solution. One equation with two unknowns, there is no one solution. Any idea how many there are? Well, we've got two here that we've seen. But could we not pick any value for x and find a solution for y? Yes, we could. So if we have one equation with two unknowns, there are infinite solutions. And this is where we then come to simultaneous equations, right? We've got two equations, two unknowns, and as a result, we can solve. Okay, so that's just a little bit of a background as to why we have two equations at the same time or simultaneously. Okay, because we need the two equations to deal with the two unknowns and come up with one solution. And as I mentioned before, that will be x equals blank, y equals blank, and it works for both equations. Cool? So that's the little intro. Now the question is, how do we actually deal with the question? How do we actually deal with these two equations? Okay, again, I'm going to assume that you don't know, and I'm going to show you my method, cool? And then we can talk it through, and maybe you'll like my method, but maybe you'll want to find your own way with it. So typically, what I do is I'll write out the two equations again, line them up nicely, give myself a little bit more space. Cool. And then I like to label them equation 1. I can tell that means equation 1 because I put my 1 in a circle. And equation 2. Cool. So, what did we say was the problem? The difference? What are we dealing with? We've got this x, and we've got this y, this y. Yeah, so the reason we can't just solve equation 2, for example, is because there's two variables, two unknowns. So we want to find a way of cancelling out one of the unknowns, leaving us with just one unknown, for which we can then solve, and we can use that solution to find the other unknown. Okay? So that's a number of steps there. We'll do them one at a time, and then we'll go over them and practice, and hopefully we'll find our way forwards. So we're looking to cancel out, let's pick x's. For this question, I'm going to pick x's. It is slightly easier, you'll see why. But we're going to start simple. In our first equation, we've got 2x. In our second equation, we've got just x. The goal in the first instance is to make those x values match, right? I don't want a 2x and an x. I want a 2x and a 2x, or an x and an x, or a 9x and a 9x, or even a 3x and a negative 3x. Okay? Again, we'll come on to how that works in later questions. But for now, the basic idea is, rather than having this x, I want to have it be 2x. So what I'll do is I'll multiply the whole of equation 2 by 2, which gives us, can you talk me through it? Yep, 2x minus 8y equals 8. Great. And then we can label this equation 3, always keeping track of all of our equations. So this is great. Now we've got a 2x and a 2x. Great. One 2x is in equation 3, one 2x is in equation 1. And so let's now line these two equations up next to each other. And this is another thing that you may not have known that you can do. It's okay to double equations as long as you double everything. You can also subtract one equation from another. So 2x minus 2x will equal 0. Cool? And that's the cancellation we're looking for. So let's go ahead and do that. And again, it's going to be the whole equation subtracted from the whole equation. 2x minus 2x giving 0. Now you have to be careful with this one. Minus 5y minus minus 8y. When you minus a minus, it resolves in a plus, yes? So it's minus 5y plus 8y. Positive 3y. 11 minus 8, 3. We've gotten rid of one of our unknowns, and we've got an equation now with one unknown that we can solve. Divide both sides by 3, y equals 1. Cool. Now we're going to substitute this in to one of our equations. Y equals 1 into, let's say, equation 1. The way I like to do my substitutions is I will write out the equation, and then wherever I see a y, I'll put a 1 in brackets. 2x minus 5 brackets 1 equals 11. 5 times 1, 2x minus 5 equals 11. Let me just give myself some more space here. Add 5 to both sides. 2x equals 16. X equals 8. So y equals 1, x equals 8. We know that's the case for the top equation. Let's check. Let's check our working. X is 8. 8. Minus 4y. Y is 1. 4 times 1 is 4. 8 minus 4. Oh, look. It's what we were expecting. Okay, so we found solutions. The value of x is 8. The value of y is 1. And those are solutions that work for both equations. Cool, so there's a brief introduction and a first run through of how you would tackle simultaneous equations. I've got some other questions prepared that we can practice together so you can learn that method. But perhaps we'll do that when we've got a bit more time. Okay, cheers.